Hello students, this is Amuda R, Assistant Professor, the Department of Robotics and Automation. Our subject code is MR3491 and our subject name is Sensors and Instrumentation. So today we are going to discuss about our second unit, part 4. The next topic is a range sensor. Next topic is range sensor. From this we will discuss about the RF beacons, ultrasonic ranging, reflective beacons and laser range sensors. So RF beacons, the first topic is RF beacons. So first of all, beacon is a transmitter. What is meant by beacon? Beacon is a transmitter. It's a small device. So it known the location. Why we are using the beacon means for identify the location. For identification purpose we are using the beacons for identify the objects, right? So it may be a continuous or periodic signal in a limited information content, so which is used in mostly Wi-Fi, Bluetooth, RFID like. So RFID, radio frequency identifier, RFID is a tag. So in tag there is a beacon. So beacon have a unique identification number. Beacon have a unique identification number, and that calculates the distance to the beacon and the people. Okay, so people will have the RFID means it's a one type of beacon. So it have a identifier. So from that they can access what they want, if known only. Okay, based on the data, it may be a coupon, video, form, URL, other forms of information the data will have, right? So if this is the beacon, right? So if this is a beacon means is a mobile phone which have the browser, another one is have a HRL, and so these are all have some apps. So the apps will run by only by transmitting beacons transmitting the data, right? If this URL run by beacons transmitting the data, so the contact between only the beacons and the appropriate mobile phone only. So not another people using this. So most of the beacons today use the BLE technology, that is Bluetooth Bluetooth types BLE technology, because of its low power consumption. That's why they are using the BLE technology. So which allows the small amount of data transmission, and which why most beacons only transmits their IDs. So beacons consist of maximum of 3 values. One is a UUID, another one is a major value, another one is a minor value, that is university unique identifier, right? So this is the end-to-end beacon system. So here there is one beacons, that is ID is 001. Another one beacon is ID is 007. If 001 beacons is connected with the mobile phone, maybe in this mobile phone connected via the BLE, right? That is a Bluetooth. It's connected. So this Bluetooth, this mobile phone will inform to beacon server. It send the data to the server, beacon server. So here I am near the 001, right? So after that, this beacon server give the information to the third party or that content that may it send also receive the content. So it also get the content and data for a 001. What is the content? They are maybe the employee, they are maybe some client likewise. So if their employee means if they have a ID card using the RFID tag means they will use the beacons, right? So after that that data will give to cloud messaging, that is send push notification. Then cloud messaging gives the confirmation to the mobile phone, right? That may be a one app. So likewise Here is the ID 007. So this beacons use some other devices, not this device, some other device with a different application. Okay, so this is the end-to-end beacon system. So beacon enabled applications. So these are the enable system. So network of deployed beacons, Bluetooth enabled device with relevant permissions and management platform. So these are the beacon enabled system. So these are having the content. So next one is a ultrasonic ranging. Ultrasonic ranging is a sensor which is used to measure the sound by measuring the distance. First they have to know what is the sound, then only they measure the distance, right? So for example, if when an object produces sound, the air molecules are pressed against to each other. So when the sound will come, the air molecules are pressed, right? So there is a change in air pressure. So then it transmits the energy to each other. So this causes the vibration, then this moves through the air and undulating motion. So this undulating motion is called frequency, so which is expressed in the hertz. Okay, the number of sound waves per second. So we have to measure the sound by the frequency. So here the ultrasonic sound, here the ultrasonic sound emit the sound pulse. Okay, so you have to notice what's the time and what's the time it emits a sound. Then that sound will be reflected and gives again to the as a echo, receive as a echo. So we have to measure the distance, then only we have to find we can find the what is the sound. So in this time the ultrasonic ranging sensor is used. Here the sensor is composed of two ultrasonic transducers. One is a transmitter and another one is a receiver. Transmitter outputs ultrasonic sound, which outputs ultrasonic sound pulses, and the receiver listens what is the reflected waves. The receiver listens, but transmitter outputs the ultrasonic sound, right? So these are the two ultrasonic transducer. One is a transmitter and another one is a receiver. Here is the pinout. Here is the ultrasonic range sensor. This is the sensor. Actually one is for trigger and another one is for echo. There is a 4 pins. One is a VCC, another one is a ground, one is for emitting, another one is for echo, so reflecting sounds. Okay, here so the sensor has a 4 pins. One is a VCC, ground, so VCC to 5 volt. Okay, so ground pins to we will give the ground pin to the Arduino board, right? So and the trigger and echo go to any digital Arduino pin. Okay, using that means a transmitter and the receiver, right? So and with the echo pin we listen the reflect here. So using the trigger pin we send the ultrasonic sound. Okay, that is the transmitter. And the echo pin we listen the reflective sound. What is the sound? If I am saying A, means that is the transmitter, that is the ultrasound wave. If I get the echo of sound A, that is reflected signal, means that is that pin will be a receiver. Okay, here is the original wave. So original wave is indicated in a orange color and the reflected wave is indicated in a blue color, right? So one is a transmitter and another one is a receiver. So this is the object. So this is the ultrasonic ranging sensor, which is used to sense the sound by measuring the distance. Okay. Next one is a reflective beacons. Reflective beacons operates on the principle of passive retroreflection. Passive retroreflection. This is also same as the beacons. Beacons in a beacons it's only transmit some data, but in reflective beacons it again gives reflect some, that is receive some, maybe a light or data, that may be anything. Here I give some examples. uh, Plastic, aluminum or diode bounce light waves, enhancing a visibility or enabling detection without power. So these devices use the surface. If the beacons emit the signals, but it receives the signals. But in reflective beacons, it receives the signal again. Here the passive retroreflection means this do not require batteries. So they reflect energy such as car headlights or search radar, that is directly back to the source rather than scattering it. Actually it's like a beam, it just directly gives the light, it does not scatter. Next one is a material interaction. This is for to create a strong contrast against the surroundings. And next one is signal return. So that is the reflective beacons. So types of reflective or passive beacons is visual reflectors, active frequency selective surfaces, and Rocco reflectors. So these are the types of reflective passive beacons. So here is the beacons broadcast, which uses the BLE technology in a Bluetooth device, and identify if receives the identification from the mobile device, then it gives to the backend service, that is it receives object URL to download something, and it look up object with the identity, right? So it transmits the identity and it receives some data, that may be a downloaded data or object, a download or object or URL, that may be anything, and that may be a word data also, right? This is the types. Next one is a laser range sensor. So LiDAR. Laser range sensor is to measure the distance to the object surface. To measure the distance to the object or surface with the laser. It uses the LiDAR, light detection, laser imaging and ranging. It uses the light detection of laser imaging and ranging technology. So here the LiDAR laser emits the laser pulse to an surface. The pulse is reflected. So we have to calculate the distance between the surface to the that object to the surface, right? So it will be calculated like distance is equal to speed of light into time of flight divided by 2. Here I explain the concept of a LiDAR. Here is the flight. It emits some pulses or lights. So the flight must have to measure the what is the distance between the surface to the flight. Okay. So for that they are using the LiDAR. They are using the light detection ranging sensors. So this pulse is emitted, then it reflected again. So by reflecting the pulse, it measures the distance. Okay. For example, these lights have a laser scanner emits the infrared pulse which reflect off surface of the earth and object on it. The returned pulse are captured and recorded. Here there is a GPS, here there is a IMU for the detection. So IMU is a inertial measurement unit which gives the previous orientation of a scanner. And also GPS which gives the previous location of the scanner. Here is the GPS base station. By using these we are identify or measure the distance from the flight to the surface, right? So LiDAR system types based on the platform. It's a ground based LiDAR, airborne LiDAR, spaceborne LiDAR. It's a ground based LiDAR is looking like this. Airborne LiDAR, that's I explained here. And this is the space-borne LiDAR which is used in satellites. Okay, so from the satellites also using a LiDAR to measure the distance between the Earth to the satellite, right? So it's a main components of a LiDAR system. This is the LiDAR system actually is looking like this. It's a reflected echo, and the inner part is a outgoing beam, that is light is going like this only, that is pulse is emitted like this only and also reflected through this only. Okay, it's a rotating mirror. Outer this part is called motor with the angle encoder, and this part is called IR transmitter diode, right? So this is a photodiode receiver. So these are the parts of light detection ranging system. So these are the application which is used in autonomous driving, robotics, cartography, that is 3D maps, safety, actually which protects the people from the accidents. Okay, here is some LiDAR I gave you of a TF02I LiDAR. It's a one type of LiDAR which is working like this. This is the pulse timing module which is connected to the laser, right? So here this is the light. Okay, this is the light, and also pulse timing module which is connected to the avalanche photodiode. Avalanche photodiode here we are using to convert a weak signal into a strong signal, strong light in the, okay, right? So which is connected to some car. Okay, so this is the one type of LiDAR, that is TF02I, so which is used in our car. Okay, this is a laser range sensor LiDAR. Okay, thank you. If you have any doubts or any question, please drop the comment below. So for more lecture videos, visit our website smit.edu.in and follow our Facebook page SMIT Chennai and follow our Instagram page SMIT Official Chennai. Thank you.